It's a beautiful day in this neighborhood, a beautiful day for a neighbor. Would you be mine? Could you be mine? It's a neighborly day in this beauty wood, a neighborly day for a beauty. Would you be mine? Could you be mine? I have always wanted to have a neighbor just like you. I've always wanted to live in a neighborhood with you. So let's make the most of this beautiful day. Since we're together, might as well say, would you be mine? Could you be mine? Won't you be my neighbor? Won't you please? Won't you please? Please won't you be my neighbor?
Oh, hi. Didn't see you there. How's it going? Decided to take my banjo out. I guess since you're here, we might as well talk about the physics of sound. The first thing we'll talk about is pitch in music. In music and physics, pitch refers to frequency. So when I strike this fifth string, this is a G string, this has a frequency of 395 hertz, or 395 cycles per second. That means every second, this string is vibrating 395 times back and forth. Now, I could strike this string really softly, or strike it harder, and you'll notice that it has the same frequency, but the difference is the loudness. So the harder I strike the string, the louder it's going to be. It takes more energy for me to strike the string harder than it does to strike it softly, so loudness is equal to the amount of energy that I use to strike the string. If we were to measure this wave, or look at this wave itself, we would see that the amplitude is going to be higher when I strike it harder. So the loudness in music is equal to the amplitude in physics, and we could say that that's equal to how hard I strike something, which is equal to the amount of energy I exert. So loudness, amplitude, energy, and striking something are all directly related. We'll edit that part out.
Good.
Yeah. Let's talk about natural frequency. This string, the second from the bottom, is a B note, which means that it vibrates at that natural frequency due to the length and the thickness of the string. If I move my finger down 3 frets, I've shortened the string, and now it vibrates at a D note. So that's its natural frequency, or the frequency at which it'll naturally vibrate at. Now this bottom string, if we could zoom in, please, fiance. This bottom string is also a D note. So that's a D, and then the 3rd fret down on the B is also a D. So they're vibrating at the same frequency. What I could do is, if I strike the 3rd fret on the B, which is a D note, it'll then cause the other D notes to vibrate as well, because they have the same natural frequency. And you can hear that echoing sound. That's that other D string vibrating. And this is how we can tune instruments through resonance. So resonance is when one object of a natural frequency causes a second object of the same natural frequency to start vibrating, and if they're in sync, they will increase in amplitude.